Example number 6 gives us the parent function y equals x squared, and they want us to do a horizontal shift 2 units to the right, they want us to do a vertical stretch 3, well, a factor of 3. Then they want us to vertically translate 5 units up. So now how do I do that? Well, I say y equals x minus 2 in parentheses, put the square, plus 5, right? Is that right? So now the question that I have for you guys is, do I just put I just want to put the 3 in the front. I think I made a mistake on that last example. See, if I multiply the 3 by everything, then I get plus 15 at the end. Right? So I really want to be careful how I do this, because I really want that plus 5 at the end. So anyways, what I need to do now is expand that. So I've got 3 times, and then over here what I'm going to do is I'm going to multiply x minus 2 times x minus 2. So I get x squared minus 2x minus 2x plus 4. So that becomes x squared minus 4x plus 4 plus 5. When I push the 3 through, I get 3x squared minus 12x plus 12 plus 5, or 3x minus 12x plus 17. Now if I do it that way, I get a plus 17 at the end. If I do it another way, let me show you what I'm talking about. If I do this like this, and I say y equals x minus 2 squared plus 5, and then I take this whole thing and multiply it by 3, I end up with 3x squared minus 12x plus 27. And so which one's the right one? Well, so I've got two choices. I got that choice, or I got that choice. And so that's really what example number 6 wants us to determine, is which one actually does the transformations that the textbook asks us. So how can I determine that? Well, I'm going to have to graph it, right? So if I come in here and I look at I'm going to use my fancy calculator here. And if I go to graph, I like using this calculator. I mean, obviously you should probably use your TI-80 3 or 84. But I like using this one because you could see it. It kind of graphs it as you enter in the information. So that's the original function. Alright, and so what the textbook wanted us to do was to take that and shift it 2 units to the right, then increase it by, or stretch it vertically by a factor of 3, and then move it 5 units up. Now, if that's the case, if I move up 5 units, if I go up 5 units and over 2, my vertex for my parabola should be right here. Right? It should be right here at 2, 5. That's where the vertex should be, is at 2, 5. So let's try it. So I'm going to start with x, and just so you guys can see what it does, we're going to square it first. And then I'm going to enter in this minus, and then I'm going to put the 2 in. Alright? So I've shifted the graph over. The red graph goes over to the blue graph. So far so good, huh? And now what I want to do is shift it up 5 units. So I know how to do that. If I hit plus 5 here, that gets me right where I need to be. But now I need to stretch it vertically 3. And I'm going to slide this down a little bit so we can see. Now stretching it vertically will make it skinnier. If I put the 3 here, it stretches it. But now if I add a second set of parentheses, oh, it won't let me do it. Well, let's just do it this way. We'll say 3 times minus 2, 2. Now, by doing it that way, where did the green graph go? Which one's right, the blue or the green? Which one's correct? The blue or the green? Well, let's see. We said that the original function had to be shifted 2 units to the right and 5 units up. Well, which one of those is shifted from the red function 2 units to the right and 5 units up? The blue or the green? Blue. The blue. So we have to remember that it is the constant in front of the function f. So the order in which we apply the scale factor matters. Okay? Does that make sense?